In this video, we are going to do 16.03 snoc. All right, so I have it downloaded and opened up in Racket. So let's just look for the problem statement here. Problem A, notice that the data design steps is done above. All right, so here's the data definition. We have an NE list of numbers. This NE right here, it's short for non-empty, right? I just took the two letters for non-empty and stuck it here. All right, so an NE list of number, non-empty list of number, is one of either cons, number, empty, right? So this is a little new. Usually we just see empty here, right? But in this case, a non-empty list of number is always going to have at least one number in it, right? It's never going to be an empty list, right? So there we go. That's the first case. The second case is cons, number, NE list of number. So this is doing a self-reference, and this allows this data type to grow arbitrarily long, right? So it can be 2 long, 3 long, 4 long, infinity long, etc. And here is the template for a non-empty list of numbers. All right, design a function snoc that behaves like the opposite of cons. It consumes a number and a list of numbers and produces a new list in which n has been inserted at the end of the list. All right, so for example, snoc 3, this is the first argument, and then cons 1, 2 empty, produces this list, cons 1, 2, 3, all right? So let me just show you guys what the difference is between snoc and cons, right? So we do cons, change this to cons, right? So cons 3 onto cons 1 on the cons 2 empty, right? So this, yeah, cons, yeah, that's right. We should get this, right? Cons 3 on the cons 1, 2 empty, right? That's what cons does. Cons puts this 3, right? This 3 in front of cons 1, 2 empty. But for snoc, right, we want this 3 to be way at the end, right? So we want to produce cons 1, 2, 3 instead of cons 3, 1, 2, right? So yeah, stick this 3 at the end. Whereas regular cons, if this were a cons call, this 3 would be in front, producing the list cons 3, 1, 2. All right, so use the pattern above, treating n as auxiliary data. Finish the uncompleted function design steps 1 through 5 above. All right, so pause the video and try to work through the problem for snoc on your own. I'm gonna go over spoilers in 3, 2, and 1. All right, I'm assuming that you guys took a good swing at it, so now let's go over it together. So we have the signature here. Snoc consumes a number and a list of number and produces a non-empty list of number. Produces a list where n is put at the end of the list, right? The most right side. All right, so signature, purpose, let's step this out. So define snoc n, and then we'll do num list. All right, so this produces a non-empty list of number, right? So you may be tempted to put empty here, but that's not, it's not a type of non-empty list of number. A non-empty list of number is one of either cons number empty or cons number list of number, right? So empty does not fall into the classification of non-empty list of number. So instead, let's just grab this first case here and just paste it in like so. And in place of this number, right, we're just going to stick in the n that we get passed into this function call. All right, so now this is a good stub. Now let's run. Let's write some examples. Check expect. We're going to do snoc of, let's say, 7, 6, empty. All right, what should this produce, right? Well, we should produce a non-empty list number where 6 is put at the end of the list, right? So this would just produce cons 6 empty, right? It's at the end of an empty list, right? And you might be wondering, like, hey, how come we can, how come this can be empty, right? We can do snoc 6 of empty. Well, because the argument that snoc takes in here, it is a list of number, right? We're producing a non-empty list of numbers, but we're consuming a list of numbers, so it's fine. All right, let's do another example here. So check expect. Snoc, let's say 2 on the cons 7 empty. All right, what should this produce? Well, we want this. Snoc puts things at the end of the list, right? And this is the given list, so we want this list. We want to produce the list with 2 at the end. So cons 2 empty, right? So we get the list 7 and 2, right? Like so. Let's do one more. Let's do these examples they give us, right? This is the 3 long one. So check expect. This, right, should produce this, right? It sticks this 3 all the way at the end. If this was a call to cons, it would, again, we would produce 3, 1, 2. And in this case, if this was, the snoc was a cons, right? Cons 2 on the cons 7 empty, then this 2 would be in front. Anywho, that's a good set of examples. And we get some mismatches here, but that's just fine. Just comment the out sub, grab the template up here, and we can use this as a scaffold. Rename this to snoc. This snoc function takes in 2 arguments, right? A number and a list of number. And we see it in the stub here, so stick those arguments in, and we are good. Hopefully this is all the mental scaffolding needed to write the solution for snoc. I'm gonna go over spoilers in 3, 2, and 1. All right, I'm assuming that you guys took a good swing at it, so now let's go over it together. All right, so for the first case here, right, snoc 6 onto the empty list, right? This is gonna be this empty case here. We want to produce pretty much this, right? But in case, instead of 6, it can be the n, right? So there you go. All right, so that's the base case done. Let's do the other cases, right? For a 1 long and then 2 long. So for this 1 long case, right, what do we want to do? Well, we want to produce a non-empty list of numbers, right? And, you know, we had to use cons here because we had to produce a non-empty list of numbers. All right, so cons, and then we're going to take the first list, right? So in this case, it's going to be 7. And then what do we want to do next, right? What do we want to cons it onto? Well, we want to cons it onto the rest of the list, right? Snoc onto the rest of the list. And this base case is what is going to stick the 2 at the end, right? Like so. So this 2, so at the first iteration of this call, right? Snoc 2 and then cons 7 empty, right? Cons 7 empty is not an empty list, right? But it is, you know, it has something in it. So we're going to take this 7 and we're going to cons it onto the next recursive call, which will then cons 2 empty. And then this will again return, and then it'll produce the correct results. All right. So again, this base case is the one that's putting it at the end of the list, right? These other cases are just putting things in front, right? So for this call here, snoc 3 on a cons 1, 2 empty, right? This base case, cons 2 empty, is what is going to put the 3 all the way at the end here on the right side, right? Like so. Anywho, if you run up, likewise, I forgot that I had to put n as auxiliary data, right? It comes along for the ride, right? Snoc takes 2 arguments, and yeah, we had to pass it in. All right, so all 3 tests do pass, and that is pretty much it for snoc. All right, so hand it into the website and make sure it passes all the creator tests, and yeah. Anywho, that is about it for this one, and I will catch you in the next one.